So, in this episode, we're going to cover a simple topic where we're going to convert decimals to binaries, and hopefully, we know this how we do it. You might have learned this in your embedded system subject. Regardless, um, when we're talking about uh, coding this, we'd also use few other concepts through dynamic memory allocation and pointers. So while starting, what I'd want the decimal number from the user. So that is in the main function, integer main, and say I take another integer, decimal. It's just a variable, and now I need this as an input. So I'll tell the user to give me uh, enter decimal. So yeah, now, this is what will be displayed for the user. And then I'd also want to scan this so that I can push it to the variable decimal. So scanf, and since this is an integer, it's the format specifies %d and ampersand decimal, so dc. So when we're doing this, we've successfully taken the input from the user. And what I'd want to do is there's this if condition, because if the decimal is equal to 0, then I can't divide this by 2. So I'd just print 0 again. So printf 0, right? Uh, Now, yeah. So this should print 0. Now, the thing is, if it is not 0, I'd want a specific function that converts decimals to binary, right? So I'll just name it like D to B. And D to B of our argument should be a decimal, so that's obviously DEC. So I think this should finish off our main function, and it should give you an idea of what we're doing. So now what's left is I need a function d to b, right? Now I can make this a void function, um and the parameters I make it as integer list, right? Now, okay, it's not a list. Yeah, it's just a decimal, so integer x. So since it's taking an integer value, decimal, so I'll just take it as x. Then, um, now what do we do with this decimal number? Now there are two things we can do. First is we need to create it such a way, we need to find the remainder first, right? And we also need to get this value x, that's decimal, to keep getting divided by 2. So let's do that. So let's create integer r, that's the remainder, equal to r mod 2, right? So that should give us a remainder, and this remainder should get stored in a list. So let's get to that, but before that, our integer x, right, is equal to x divided by 2. And this also gets recursive. Now, um, since we're talking about lists, there's this problem. We do not know how big our binary is going to be because we do not know the number which the user is going to input in. So if I'm just creating a variable like list, I need to know the size because I just can't declare list like this, right? So instead of that, what we're doing is to create a pointer. Let's create list as a pointer, and with this we'd also create another variable called size, and let's keep size as 0. initially, and just to keep another variable, like to know the place or index in which our list is appended with. It's more like an array more than a list. So let's just keep another variable called head. And for now, since our list is empty, we'll keep head as -1. And obviously, our list is also null. And once these are done globally, we can try to start appending our variables remainder and our uh, decimal number x. So now x should keep reducing. So let's keep an if else condition over here. So if x, so we terminate this if x equals 1, right? So if x equals 1, then we need to add 1. But before that, so the list um of yeah, so I need to add 1. And obviously this is kind of wrong, but we'll get to it later. And if x equals 1, what I'd want is to print the result also, because we're like done with the whole thing. And obviously the result, the parameter, or the rather the argument should be list, right? Because we'll understand that also soon. So now what comes in our else condition is that we'll have to add like this r. Uh, so that's only if x is not equals 1, we like continue dividing. So x divides 2, like x divided by 2, and the remainder also is collected. So how do we add this to our list? Since we created list, so when we calculate the binary version, what we do is we add it to the list and then we print it in reverse order. So now how do we add the remainder to the list? So first thing is we need to increase the size. So size plus plus. And after this, we need to allocate some memory, right? So list equals to realloc um list, right? And obviously this is size times size of integer. Now, once you've created your list, now say we give a dummy number like 10 or something. So if 10 equals 1, when we keep going, we understand that size increments 1 through this function, right? Now, in this list, I want to add the remainder. So list of the head. Now, even the head keeps increasing, so it's going to be plus plus head, right? So this equals to our remainder. Now we've added a remainder to the list, and even the size keeps incrementing. Now we should also understand that once we divide, we should not stop there, right? We should keep dividing. So a good way to do this would be recursing by basically calling the function again. So DTOB, that's decimal to binary of the same number x, right? So this should cover that. Now there's something missing over here, because when we do if list of the head equals 1, we can't do that because here list is not even created. So list equals to realloc. um so it's the same thing, list of size times size of int. And before this, we also need to again increase the size. I hope it's kind of getting clearer now on what's happening. So, yeah, so now that we've got the idea of how to convert decimals to binary, we'd have to print our results. And this is obviously even called in our decimal to binary function. So again, let's create a void function and let's call it result because that's what we named it before. And this has a parameter of a pointer, right? That is our list. And here we just give a basic for loop where we're printing the list in reverse order because that's how we also read it once we solve the question of converting decimal to binary. So for integer I, say, equals, so this integer I equals to the size minus 1, right? Because that is the, now we kept incrementing the size and we got the full size of the list, right? So we can use it directly. So integer I equals to size minus 1 and this stops till I is greater than or equal to 0. Also, um we decrement it. So it's, we're printing it in reverse order. Now, yeah, so printf, it's again an integer, so percentage d, and yeah, percentage d, and we printed list of I. Yeah, so this we're done with the code. It's not that hard. I think once we get the logic of pointers and dynamic allocation, it's quite easy to understand what's going on. So this is what we've done with. So let's save it. Hopefully it runs well. So I've using GCC and I've installed that. So how do we check that? You can just do GCC hyphen hyphen version and make sure it's installed. And um okay, so we can start running this. Okay, so before that, there are a few things we forgot. Obviously, we have to add a basic files, right? So hash include standard input output dot header. And also, if you want or not, you can just also include standard library. So yeah, so with this, you can say the file. Um, yes. So with this, we can start. So I guess there's an expected semicolon also. So it's in line 12. All right. So this is not comma, it should be semicolon. Yeah. So once we're done with most of the bug fixes, which you can check in problems, then we can go to our terminal. I'm using bash. Make sure you've opened it in the folder you've saved the file. Then you can use two commands, that's ls or cd. So yeah, so now since I'm using GCC, I just type the file name recursion.c hyphen o dash. So there's an error over here where it's okay, I didn't save it. So let's save it and then run it again. Yeah, so now you see that it's cleared most of the like it's compiled, and then now we can run the code. So let's enter a decimal, say 5. It should give us 101, right? Okay, so we've got a problem here. Let's read and understand what went wrong. If x equals 1, that's where we terminate the full recursion. Size increases, list, yeah, then list of head equals 1. Yeah, this is correct. Then result of list, integer r equals to r mod 2. It's x mod 2, right? I mean, that's common sense. So yeah, I'm saving the file again. Let's run and check it. Now I'm compiling it, running it again. 5, yes, so now we get 5, so it's 101, which is correct. Now if you are getting a bit more confused, I can run it again and show it with 6 also, and that's 110, which is also correct. So with this we understand that, yeah, so we're like dynamically allocating things. So a good practice is to also free the list, right, before you kind of just leave the code. So let's compile it again after I save it. Yep, and testing. So let's give 10 now. So we know that the code's running well. I think everything is sorted well too. Good. So with this we conclude. See you later.